Okay, this is the pretest or the test review for Unit 3, which is functions and relations. And the first question asks us to write the ordered pair for each point. So the other word for an ordered pair here is a coordinate, which means we're going to put something in parentheses here. We're going to list the x value and we're going to list the y value. So the x value is the left and right component, and the y value is the up and down component. Now you should be able to see that anyway just by looking at this picture here. You can see that the x goes left and right and the y goes up and down. So for coordinate A, if I start from the origin, I go across to this point here, which is -5. Oops. And then I go up 1, 2, 3, 4 squares. So -5, 4. You can also see from this point as well that the y value is 4 and also that the x value is -5. So that's another way you can look at these questions as well. B, we go across 6 squares and then go up 2 squares, so that's going to be 6, +2. C, we go across 1 square, but then we go down 3 squares. So to show that we go down 3 squares, I'm going to give it a negative number. But also notice that C would be right where -3 would be on the y-axis. And for my last point, D, -7, go across to -7, and then I go, across to -6, and then go down to -5. So -6, -5. Now the other possible question that sometimes can be asked as well is points that actually lie on the axis. So I'm going to create a point E, and I'm also going to create a point F. Now for E, I don't actually have to go any squares at all across. So for my point E, I don't go any across, but I do go up 1 square. And for point F, I go across 3 squares, but then I don't go up any squares at all. So I could just list that as 3, 0. Now let me get rid of this, and let me make sure we actually finish the whole question here. It said write the ordered pair. We certainly did that part. But also name the quadrant in which the point is located. Now when we come to label the points, the top right is the first quadrant, and then we go around counterclockwise, like this. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. So A, you can clearly see, is in quadrant 2. B was in the first quadrant. C was over here in our third quadrant. C is in our fourth quadrant. And D was in our third quadrant. Now there are some characteristics you can use if you're asked to think about which quadrant something's in without actually plotting it. So if I was to make up a coordinate like 5, -3, then in your head what you've got to think about is, oh, I'm going right 5 squares, and then I'm going down 3 squares, so you know you're down here, and then just remember the 1, 2, 3, 4. So I would be in fourth quadrant for that question. So you don't always have to make a 100% accurate picture if you want to find which quadrant something's in. Just a little idea like that should probably help. Okay, for our next question, it says express each relation as a table, graph, and a mapping, and then determine the range and domain. So first of all, I have some coordinates, so I can easily fill those into a table here. Making sure the first coordinate is x, and the second coordinate is y. Now, when I come to draw my mapping here, I can see all these numbers are different, so I'm going to have a unique number for each of these. And I can also see here that I got some repeat numbers here. I got 2 appears twice, so I don't need to write 2 twice, I'm just going to write it once. And I'm making sure as I'm filling this in that I'm putting the numbers in numeric order as well. And then I just join them up, so -5 goes to -4, -4 goes to 2, 0 also goes to 2, 1 goes to 3, and 2 goes to 4. As it comes time to plot those points, remember I'm going to do the across first and then the up and down second. So -5 means 5 to the left, and -4 means I'm going to go 4 down. So that'll be my first point. -4, 2 means I go 4 to the left, and then down 2. Oh, sorry, up 2, because it was +2. rid of that one. Unfortunately, I got rid of my other point as well. Let me put that back. 0, 2 means I don't go across any at all, but I go up 2. Excuse me. 1, 3 means I go across 1 and then up 3. And 2, 4 means I go across 2 and then up 4. So that would be my plots. Domain is which x values I have. So my domain would just be a list of all these numbers separated by a column. So -5, -4, 0, 1, and 2. And my range is just the y values that I have, which was -4, 2, 3, and 4. Notice I'm not putting the 2 twice because I already have that. Now as we move on to question 6, this time from each of these different options I've got to list the ordered pairs, or in other words the coordinates. Let me give myself just a little bit more space here. And the table's the easiest one of all to do because it actually looks like a coordinate straight away. And I'm not going to rewrite all these, I'm just going to go ahead and do that. Now when I come to my mapping, the first number over here is the x and this is the y. So 1 goes to -1, 3 goes to 4, 5 also goes to 4, and 7 goes to 6. So fairly easy to do our list of coordinates there. From our points, we're just going to make sure we don't miss any as we go along. So I'm going to start with this one on the left first. I go 3 across to the left, which would be -3, and then I go up 1 square. This one here, I go 2 to the left, which would be -2. Then I go up 2 squares, so that would be +2. Across 1, so -1 to the left, and then down 2 is -2. And then on the right hand side of the y-axis, this one would be across 2, down 1. So 2, -1. This would be 2 across and then 2 up, so 2, 2. And our last point is 3 to the right and 1 up, so +3 and then 1. Moving on to the back of the worksheet, we have to determine whether the following relations are functions. And there's 2 things that we're really looking for here. One is no repeat x values. And the other one is, does it pass the vertical line test as well? So if we draw a vertical line, if it passes through more than 1 point, then we know that it's not a function. So for this first one, that would actually be the easiest one of all. If I was to draw a vertical line here, and it passes through 1, 2 points, as it passes through more than 1 point, then I can say no, that it's not a function. And if I can do that anywhere on that graph, that means it's not a function. Now for this one here, I can see that when x is 4, y is 2, but also when x is 4, y is 5. So I actually have 2 coordinates that have the same x value, which means this one is also not a function. Now when I come to look at this one here, I'm looking for my vertical line again. That goes through 1 point, through 1 point, through 1 point, but when I get to this line here, you can see that it goes through 2 points. Now it only has to happen at one place to make it not a function, which means that one is not a function. The table of values is probably the easiest one. All we have to do is look at the x values and make sure they're all different. I don't see any the same here. -1 and 1 is the closest. So actually, is this one a function? Yes, this one is a function because there are no repeat x values. And you could look at the last one. You could even do a table of values possibly for all these coordinates. But there is nowhere where I can draw a vertical line that it'll pass through more than 1 point. Now, when you're drawing a vertical line, make sure that you don't include the x-axis though. All we're looking at is the actual graph itself, not the axes. I can't see anywhere where I could draw a line for that that will pass through more than 1 point. So my answer to that question would be yes, that is a function. For our last section, we're going to substitute values into formulas. So f of 4 means I'm going to use the function f, and wherever I see x, I'm going to write 4. Now remember, when you substitute, you should be putting parentheses around whatever you're substituting. So x is 4, and then plus 2. Now you can do this straight on your graphing calculator. We can just type these straight in. So if I click menu and then run, I can type this in just as it appears now, using the parentheses. And the answer is just just 14. Move across to this side. This one says f of 8, so write out the formula again. Where it says x, write in what the x value is, but plug in the parentheses as well. And then I can do the same thing. So 3 parentheses 8 plus 2 is 26. Remember what you're doing here is when two things are next to each other, you're multiplying them together. So 3 times 8 is 24, and then add on 2 is 26. Okay, the next one says g of something, so I'm going to use the function for g here. So where it says x squared minus x, and I'm going to plug in negative 2. So negative 2 squared minus x is negative 2. Now I got a lot of parentheses here to try and avoid making mistakes. Particularly for this one here, was a lot of people messed up on when they did their Unit 1 quiz. So what a lot of people did is, without the parentheses, they just put negative 2 squared. When actually there's supposed to be parentheses here, and if I put the parentheses in, you can see that I actually get a different answer. Whoops, I forgot to press squared. You can see I get a different answer. I actually get 4 instead of negative 4, which is what I'm looking for. Now, actually for this question, I can just type in this whole thing in one go, and the calculator will do the order of operations for me. Minus parentheses negative 2, and the answer is 6. Now, that shouldn't be a big surprise anyway, having said this was 4. Remember, two negatives, when we subtract a negative, it becomes a plus, which is why 4 plus 2 is 6. 13 says g of 2, so write out the formula. X squared plus x, substitute in 2, still keeping parentheses here, even though I could probably do this one in my head easily enough. 2 squared plus 2 equals 6. Not surprisingly, 2 squared is 4, and then when you add 2 to that, you get 6. Last two. 14 says h of negative 3. So h formula is 1/2 the absolute value of x plus 1. And now I'm going to scroll up so we can actually see that answer a little bit better. And I can also use it for this question as well. So the absolute value takes anything that's negative and makes it positive. So when I do 1/2 of negative 3, then it knows to make this negative 3 actually positive 3. And now if I enter that on the calculator, I should get 2.5 if you want to check that. When I plug in a positive number, it doesn't actually do anything. The absolute value only makes negative things positive. It doesn't make positive things negative. So the absolute value of 6 is actually just 6. So 1/2 of 6 is 3, plus 1 is 4. But you could be doing this on your calculator as well. Now, having said we can do it on the calculator, if you want to do this one, the use of parentheses is going to be important. So, as for our fraction here, I want to show that I'm doing 1 divided by 2. So I have parentheses around that. Then the 6, and then plus 1, which would give us the 4. F of negative 3, so I'm going to go back for my formula. It was 3x plus 2. Substitute in the negative 3, and then go ahead and check on your calculator. It should just be negative 7. Formula for g was x squared plus x. Plug in negative 4, keeping those parentheses there as well, and then use your calculator just to confirm that the answer is 12. And that concludes the Unit 3 pretest. Quite a short chapter. This was just 2 lessons, so one to make sure that you understand thoroughly so you can score very highly on this particular test.